So we're going to do a lab quiz by the end of the hour. And here we go. All right. So I want to take a little bit of time to I'll come back to that. Remind me to come back to that. That's a good thing to talk about. Talk to your neighbor.
Yeah.
-3 to object C, which is +6. 9 divided by 3 is 3.
The bonus like a bonus question, like extra point, or is it like an actual question?
It's a bonus.
Okay. So it's technically out of 14.
You're right on the mic.
Shoot.
Come on. Okay, correct answer is? Did you finish the lab?
I think I did, yeah. I mean, I know that I did all the work for it.
Thank you.
I don't know if I have it all written down on the same paper.
Okay. Going from 3 to 6, we're doubling the charge on one of those Q's. So we're doubling the charge on this one, which is going to cause the force to double. And because we're switching the signs, it goes from attraction to repulsion, and correct answer is B. Okay. Bountiful buffaloes.
So since because it's switching the sides of the opposite.
Okay.
Sorry. We didn't do it. So
Just look through there. Figure it out.
what's through here? Like these ones?
Yeah.
Or is that different? Okay. Okay. So,
Talk to your neighbor.
so do you how like fast do you switch? Because once
Yeah.
thank you. Once
That fast.
Okay, and there's once these electrons transfer to here, are they like stuck there or can they still move?
All I can tell you is this is metal, and this is an insulator. That's all I can tell you. It's a bonus.
It's what?
It's a bonus. Correct answer is E. Every elephant is enormous. Okay, you gotta square that. Are we good with like? I'm really hoping you get this whole like inverse squared thing. Like, gotta square that, it becomes 16. So it's on the bottom, so it decreases to 1/16. All right, with that. So you want to take this today?
Yeah, I just need to copy this over. So I messed up and didn't see this backside, so I just have to copy everything.
Tell your neighbor. Okay. Correct answer is? Correct answer is D. Here's why. Here you have K, Q, Q over R squared. Here you have K, Q over 2Q over 2R squared. So that becomes coefficient is 2 over 4 equal to 1/2. Here you have KQ over 4Q over 2R squared. So that ends up being 4 over 4, 1 over 1. Just same thing as that. Correct answer is D. Good there? Okay. lightning. A really cool example of static electricity. So, for reasons that, well, inside a thunderstorm, there's a lot of turbulence. You would not want to go flying a plane through a thunderstorm. Just a bad idea. So all that turbulence rips electrons off of molecules, charging by friction. For reasons that we don't know about, the negatives end up being usually on the bottom side, and the positives are up top. And this is not drawn to scale. These clouds are huge. Okay, these negatives repel the electrons in the Earth. They're running away, leaving the land positively charged. These electrons are not fans of that. Like, there's too many electrons. We need to find better environment. And so they send scouts out to find like a more positive environment. These are known as step leaders. This is not lightning. Okay. The step leaders continue to explore the ground around here. Josh.
Can you like see the step leaders, or are they?
Great question. No, it happens so fast and they're so faint. Usually not. I'll show you a video of that here momentarily. With a special camera, I was able to capture it. So the ground, because it's so positively charged, actually rips electrons off of air molecules, making the air molecules positively charged. And those are the things that start coming up towards meeting that. These are called positive streamers. Okay. And when one of those connects with the step leaders, then the road is connected. And so what happens is the electrons that were in that rush down. That creates light. That's your lightning. Okay. Now, when they go, remember from chemistry, when you have an excited electron, it jumps up to a higher orbital state, and then when it falls back down, it emits a photon, emits light. Well, it does. That wasn't catching any memory. Okay. And so these go fast, create light, and then just like when a stoplight turns green, it takes a while for the cars to go. So these go first, and then these have to wait for those to go. So the light looks like it goes from the ground up, but really it's electrons going from the cloud down. Okay. Okay, here's a footage of a step leader. So this happens, I'm making this up, in a tenth of a second. Okay, and once one of those step leaders reaches the ground, then a bridge is connected, and you see how the light looks like it goes from the ground up. Okay, but these are all, and this is where the forks come from of lightning. Like these guys are like, oh yeah, this way. Okay, Randall. Yep. Yep. Oh, that's just because electrons are going through you real fast. Okay. Here's some examples of some positive streamers. Okay. Okay. I want you to notice how the light looks like it goes from the ground up. Watch. See how it looks like it's going from the ground up, but in reality, electrons are going from the cloud down. Josh. because of that.
Why does it look like it's coming from the ground?
Because these guys are, oh, you can't see that. Because these guys are rushing sooner,
Oh,
and these guys have to wait their turn.
so it's like a stoplight.
Yep.
Like cars.
Mm-hmm. Good with that? Okay, I'm going to give this a shot here. Okay. This is worth it. All right. So this is just a little appreciation of physics. Okay. There's 4 fundamental forces that we know of: gravity, electrical force, strong force, weak force. Okay. Gravity we've talked about, electric force we're talking about, strong force, weak force, these you'll never interact with them on a personal level because they only happen at really close proximities, like the size of a nucleus. Okay. Think about this. This didn't strike me until a long time afterwards, but protons, where protons live, where do they exist? In the nucleus, right next to other protons. What do protons like to do to each other? They like to repel each other. They're both positively charged. So why do they hang out in the nucleus? Oh, the neutrons. They're like Switzerland. Nope. Oh, the electrons. They're like saying, stay in there, stay in there. Nope. It's because there's another force at work as well, the strong force and also the weak force. The reason why they gave it the name strong force is because it's stronger than the force of repulsion. Again, that the protons want to do to each other, and they hold those there. There's a potential energy associated with strong force and weak force. So that's what we're tapping into with a nuclear bomb. It's when we break that atom up that releases that potential energy. Does that make sense? Sort of, kind of. Anyway, that's as far as we're going to, as deep as we're going to get into these two with this class. But let's go back to gravity and electric force. It's crazy, first off, that 2 out of the 4 fundamental forces, the patterns of the equations look identical. Like, that's cool. They're completely unrelated in terms of what causes them and all that jazz. Okay, but the patterns they follow are pretty much identical. We talked about this last chapter that if any of this was changed, galaxies wouldn't exist, stars wouldn't exist, elements wouldn't be created, life would not exist. We have a similar conversation here, completely different thing, but if this was just R, not R squared, electrons couldn't be held to atoms. Like, it just like subatomic soup. No life, no chemistry, done. Even if it was like R to the 2.1 power, not just squared, but 2.1, life would not exist because atoms would pull the electrons in. No, there would be no chemistry going on. It should be just done, game over. Okay, it's like, whew, I'm really glad. Like, that's cool to me. I'm glad I'm alive. Like, I don't know about you guys, but all right. So there's that quick version. Got a lab quiz.